In this video lesson, I will be showing you how to graph an exponential growth and decay function. The first example, f of x equals 3 to the x, is an example of an exponential growth because the value of b, if it's greater than 1, it will represent a growth function for us. Let's take a look at the graph of f of x equals 3x. I will use the graphing calculator to aid us in this process. If you have anything, go to your y equals, and if you have anything in there, clear it out now. So hit the clear button. Now I'm going to type in 3 to the x. I like to get first a sketch of that graph so I can get an idea of what it looks like, and then we can now generate a table. So looking at the graph, I can see as the values of x are increasing along the x-axis, the values of y, or f of x, are going up as well. So we have an exponential growth function. Let's call up our table by hitting second graph. That's where the table is located. And I like to get the y-intercept, and I would choose at least one extra value for x or coordinate on either side of the y-intercept. Feel free to get more than one, but I typically choose 1. So -1 and 0.3, and then 1, 3. Graphing the table of values now, -1.3 and 1, 3. Again, if by further investigation, if we look at the x values as they're decreasing, so as they're heading off on the left side of the graph towards -infinity, so as they're getting smaller, we see the f of x value is getting closer and closer to the value of 0. This tells us that we have a horizontal asymptote. An asymptote is a line that your function or the graph of the function will approach, but it will not intersect. So I'm drawing that in using a dashed line here. Now I will sketch my curve in to show the graph of f of x. Label the horizontal asymptote as y equals 0 since it's represented by the x-axis. In the second example, we will do an example of an exponential decay function. Again, the value of b, if it's between 0 and 1, we see it's a representative of an exponential decay function. Again, let's go to our graphing calculator, clear out the previous function, and let's type in 1/4 to the x power. Using parentheses, 1 divided by 4, and then raise that to the x power. Let's get a sketch of the graph first on the calculator, and then we'll generate our table. So looking at the graph of this function, we see as the values of x are increasing, we see those values of f of x are decreasing. So we have an exponential decay function. Again, using our table, we'll generate the y-intercept from there. And again, I get at least 1 point on either side to get that graph. Graphing the function using my table of values, -1,4, 1.25, and again investigating what is happening as x is increasing this time, because we saw previously on the previous screen that it's getting closer and closer to that x-axis, so let's investigate that. As x is increasing, f of x is getting closer and closer to 0 again. So we have our y, or a horizontal asymptote rather, at y equals 0. So again, labeling that, drawing the curve, sketching that graph in there, the asymptote, y equals 0. You have a basic idea of how to graph exponential growth and decay functions using a table of values and your calculator.